This is inspired by a Reddit post on the Ask Math subreddit where a user noticed a connection between squares and odd numbers, and what they noticed was if you take a square like an 8 by 8 square we have here, 8 squared is 64, then you make one side of that square shorter by 1 and the other side you make longer by 1, so you get a rectangle, and the product of those two new numbers, the area of that rectangle, is now 63, which is exactly 1 less than the area of the square we started with. So the difference is 1, as you can see. This is true for any square. You may take a 9 by 9 square, 81, and then 8 times 10 is 80, so check it for yourself. It's true for any square, but more interestingly, as you continue to do this simple trick, you see that you always get the next odd number as the difference between the last two products. You reduce this side further and further, you increase this side further and further by 1 each time, and even after we cross the 0 point and move into the negative numbers, the trend continues. It's always the next odd number as the difference between the last two products. And the user wondered, why does that happen? What's the reason behind this weird behavior? What do odd numbers have to do with squares and with multiplication? And the answer is, odd numbers do in fact have a lot to do with squares, because the square of a natural number n is always equal to the sum of the first n odd numbers, right? I can show it here. Let's start with 1 squared, which is just 1. Then we add the next odd number to what we already have. We get 4, then we get 9, and then we get all the other squares. It's always the squares. It's always the next square. Okay, so they are connected, but why? We see that this connection reveals itself in more ways than one, but still, what's the reason behind it? And I will illustrate this reason with this visual trick. I will start from a 1 by 1 square, also known as the unit square right here, and I will make bigger and bigger squares of natural numbers. So now I have to build a 2 by 2 square. I will extend this square upwards and then sideways, so I just added 2 more unit squares, and then I will fill this gap in the corner. So I added 3 squares in total. 3 squares, I'll make them green, and I can now move on to a 3 by 3 square, which I'm going to build by doing the same thing again, only now the side of my square, my new square, is bigger. It's now 2. The length of its side is equal to 2, so I'm adding 2 squares on top and 2 squares to the side, but still only 1 square in the corner to fill the gap. I'll make them blue. So I've got 5 new squares, 5 new blue squares, and you probably see where this is going, but I'm going to do this one more time. The sides of the square keep growing, so I have to add bigger and bigger numbers to each side. 3 here, 3 there, but in the corner it's always 1. So I added 3 plus 3 plus 1, and it is equal to 7 pink squares. Okay, And the general formula for this is the square of the next natural number, n plus 1, is equal to the square of the current natural number, n squared, plus the next odd number, the odd number after the nth one, the n plus 1th odd number. And how do I know that this is the n plus 1th odd number? Well, I know this because I know the formula for the nth odd number, which is 2n minus 1. I can do this right here. So I'm taking n, I'm multiplying it by 2, I'm subtracting 1, I get 1. And yeah, these are the odd numbers. And they just keep going. That's 2n minus 1, the nth odd number. What about the next odd number? Well, that's just the nth odd number plus 2, right? Each next odd number is bigger than the previous one by 2, so I add 2 to this, and I get to n plus 1, which is the thing that we have here. I also have this formula right here. The nth odd number is 2n minus 1, so this is the next odd number after that, the n plus 1th odd number. And I hope it's clear how this means that this is true, how this thing follows from this thing, because this formula is recursive. So this means that when we try to calculate the square of some natural number, we refer in our calculations to the square of the previous natural number. So to take the square of 37, we have to know the square of 36, and then we add the 37th odd number. But how do we know the square of 36? Well, we first learn the square of 35, and then we add the 36th odd number. So you see how we went from 37 squared to 35 squared plus the 36th odd number plus the 37th odd number. And this means that as we continue this process, we reach a point where we say, okay, how do we know the square of 2? Well, that's just the square of 1 plus the second odd number. And how do we know the square of 1? Well, that's just the square of 0 plus the first odd number. Or if you don't consider 0 to be a natural number, you can just stop at 1 and say, well, the square of 1 is 1, because that's the unit square. In any case, what you get in the end is the sum of all the odd numbers up to the nth, well, actually the n plus 1th odd number. That's all fine and dandy, but how does that answer the original question? I mean, that's a nice picture. White plus green plus blue plus pink is 1 plus 3 plus 5 plus 7, which is a 4 by 4 square. And it's nice, but how does it relate to what we started with? You know, the 8 by 8 square that we squashed into a rectangle further and further. Well, let's go back to that. I'll make this smaller, and at first I'll start with a 6 by 6 square. How do I go from here to a 6 by 6 square? And of course I could do it in 2 steps, first to a 5 by 5 square and then 6 by 6. But what if I want to do it in one go? Well, I could kind of do the same thing but twice, but you know, I'll switch the order around a bit. So normally I would start by doing this and then doing this, but what if I do this 2 times, then I do this 2 times? Now I have a bigger gap to fill. And why is that? Well, because previously those 2 rectangles have always been just one row or column of unit squares, so they had width 1, so to speak. But now, since I'm adding not 1 but 2 to the side of the original square, the rectangles, the green rectangles, are 2 rows and columns, so they have width 2. And the gap, which used to be a 1 by 1 square, now becomes a 2 by 2 square. So let me do this. I'll make it blue. And in general, the formula for the square of a sum, which you might remember from school, is this. When you increase the length of the side of your original square by some number a, previously this was always equal to 1, but now we take an arbitrary number a, and you get the area of the new square, which is equal to the area of the old square, plus those 2 rectangles that I've colored green, which are really just the side of the old square taken a times and added 2 times to the top and to the side. So 2an plus a squared, the corner gap. It's a squared because it's formed by the widths of the rectangles. And again, this formula is taught in school, but it's not always that you're shown a visual explanation of this formula. Where do those things come from? Why a squared? Why 2an? And now that we know all this, we can finally move on to the original example, in fact, the 8 by 8 square. I'll imagine this square to be an extension of a 7 by 7 square. So an 8 by 8 square is really 7 plus 1 squared. I'm going to remove this corner square and leave this gap that we're always trying to fill. Now I'm just gonna leave it there. What I'm left with is this incomplete shape, which I can actually very easily turn into a rectangle, like so, because those 2 rectangles are always equal to each other. This is just 2n. Both are n. Both rectangles are n, so I can put them together and get this big rectangle, which is a 7 by 9 rectangle, because this is a 7 by 7 square, and we've got 2 7 by 1 rectangles on top of it. And now it might be clearer why making one side of the square shorter by 1 and the other one longer by 1 creates this rectangle whose area is just 1 lower than the area of the square, because all we're doing is removing the corner square, the corner bit, recreating the corner gap, and then rearranging those green rectangles. So we only take away 1 bit. But what about the next steps? What about going from 63 to 60? Well, here we have a 6 by 6 square plus those 2 green rectangles, which is almost an 8 by 8 square created from a 6 by 6 square, except we haven't filled the corner gap right here, right? So we're missing the blue part, the a squared part, and I'm going to put it there just for illustration's sake. Here's the blue part, but we're not going to count this. The blue part is it should be invisible to us. And I'm going to do the same thing again. This is a 6 by 10 rectangle, because this is a 6 by 6 square, and this is a 4 by 6 rectangle that we've got through the same process as before. And now you can see that this squishing of a square is equivalent to taking the difference of two squares, which is in fact another formula you might remember from school. We're taking a big square, in our case an 8 by 8 square, 8 squared. We're subtracting a 2 by 2 square from it, and this is the same as reducing one side of the square by 2 and increasing the other side of the square by 2. So we will get a 6 by 10 rectangle. We don't need the green highlighting anymore, so I will make everything white except for the negative square that we're subtracting. In fact, I'm going to make it into a separate square and make everything white. This will be our positive square, and this will be our negative square, and I'll put the negative one on top of the positive one and see what happens as I increase the number a. What happens is, of course, the negative number grows by the next odd number, like we know all squares do as we increase them, right? This is this formula right here. This is the same as subtracting a bigger number from one side of the square and adding the same bigger number to the other side of the square. And of course, the end result will be smaller than the result of the previous operation by exactly the next odd number that we added to the negative square. And I'll keep going, but this time I'm going to speed this up a little bit and go straight to the 8 by 8 negative square. So what we have here is 8 squared minus 8 squared, right? The negative square covers the positive one completely, so the difference is 0. But we don't have to stop here. Of course, we can just make the negative square bigger still, and what we're going to get is a negative number. Here's our positive square, and we see those blue squares sticking out, and there's 17 of them, which is exactly what we had here, right? So this is minus 1 times 17, minus 17 blue squares, blue unit squares. So I hope it's clear now why this thing keeps happening even after we cross into the negative numbers. And I think it's fun that to answer such a seemingly simple question, why does this one little thing keep happening as we squish the square more and more, we had to rediscover two formulas we knew from school, the square of a sum and the difference of squares, and we also learned a nice little property of squares of natural numbers, and we saw how this all plays out geometrically, and this is all I wanted to say really. So, thank you and goodbye.